Hello there, and welcome to the Sleepless Scientist, a quiet corner of the cosmos where curiosity drifts slowly and knowledge hums like a lullaby for the night. Tonight, we're setting out on a journey that stretches farther than any map can reach, into a question so enormous that it almost refuses to fit inside words. How big is the universe, really? It sounds simple, almost innocent, until you try to answer it. Then, like a dream that unravels when morning comes, the question folds back on itself. Every measurement leads to another horizon, every horizon to another mystery, as though the universe keeps expanding just to stay one step ahead of our understanding. But before we begin this quiet voyage through space and thought, I'd love if you could take a moment to like this video and subscribe, only if these calm explorations bring you peace. And when you're ready, share in the comments where you're listening from and what time it is for you right now. It's always a quiet wonder to see this constellation of listeners scattered across the world, each shining from their own corner of time. Now, dim the lights, let the hum of the room settle, breathe in the stillness, and let's drift gently into the vastness together. And if your thoughts begin to wander, that's perfectly fine. Let them go. We'll still be right here, tracing the quiet edges of an endless universe. Let's begin, not with a telescope, but with your eyes. Imagine you're stepping outside on a clear, cool night. No clouds, no city glare, just the sky, dark and deep, and above you, stars. So many stars, 1,000 pinpricks of light that seem to float just beyond reach. Perhaps one is blinking faintly, another burning steady. Perhaps a gentle breeze rustles the trees as you tilt your head back, and for a moment you feel something strange, something vast. It's tempting to think that those stars are scattered just beyond the moon, or maybe further than the sun, but still part of the same gentle bowl overhead. That's what it looks like from Earth, doesn't it? As if all the stars are painted onto a smooth black dome. But here's a quiet truth. That image, that bowl, that idea that the sky's evenly dotted with nearby stars, it's an illusion, a comforting one, but a lie all the same. What you're actually seeing is more like a time machine made of light and silence. Each star you glimpse is a kind of postcard from the past, travelling through space across incomprehensible distances. Some are 10 light years away, others hundreds, a few thousands. That means the light you see tonight might have started its journey before your great-grandparents were born. That soft glow above you isn't the present. It's a layered museum of long-ago events, arranged not by time but by direction. And even then, even in that stillness, the sky lies in another way, because the stars you can see, those few thousand scattered across the firmament on a good night, are barely a hint of what's out there. They're the nearby porch lights in a sprawling city of 100 billion galaxies. They're the sugar crystals on the tip of a spoon, while the rest of the bag remains unseen. You see, the stars that reach your eyes are limited not by how many there are, but by how far their light can travel in the time since the universe began. Think of it this way. When you shine a flashlight in the dark, it doesn't illuminate everything instantly. It takes time for that light to reach the edges. Now imagine the universe doing the same thing. It's been expanding for about 13.8 billion years, so the light from the farthest objects has been racing toward us since then. But here's the twist. The universe itself has also been expanding while that light travelled. So the actual distance to those ancient sources isn't 13.8 billion light years. It's more like 46 billion light years in every direction. Yes, that's right. The observable universe spans roughly 93 billion light years across, a sphere of everything we can, in principle, see. And yet that sphere is not the edge of everything. It's only the edge of what light has had time to tell us about. Beyond that, we simply don't know. There may be more galaxies, more space, or maybe even something entirely different, something we don't have the language for yet. But let's not get ahead of ourselves just yet. let's stay for a moment with the stars, with their quiet shimmer, with what they're not saying. Think again about that night sky, and consider this. Even the closest star to us, Proxima Centauri, is over 4 light-years away. That means the light you see from it tonight left when the calendar still read 4 years ago. Imagine lighting a candle on a distant cliff and having someone see its glow years later. That's what starlight is, a delay, a gift handed through time. And still, most of the universe remains invisible to your eyes. The galaxies beyond our Milky Way are so distant, their individual stars blur into cloudy patches. To see them clearly, we rely on telescopes like Hubble or James Webb, machines that stretch our vision and show us how crowded the dark really is. When astronomers aimed the Hubble Space Telescope at what seemed to be an empty patch of sky, a region no bigger than a grain of sand held at arm's length, they discovered thousands of galaxies, each one containing billions of stars. From what looked like nothing, everything appeared. So next time you're under the stars, remember, what you're seeing isn't a flat ceiling or a bowl of glowing dots. It's a layered archive of cosmic time, a scattering of lights from distant homes, many of which no longer exist in the way you see them. Some may have gone silent, some may be just beginning, and some may be watching back, wondering the same thing you are. How big is it all, really? It's okay not to have an answer. Tonight, we're not solving the mystery, we're floating in it. Like a leaf on a vast ocean, noticing the ripples, not the shore. The size of the universe is too large to hold in your head, but you can feel its weight, gently, in your chest. You can sense its silence as you lie back and stare upward, knowing you're looking not just into space, but into time itself. And maybe, just maybe, that's enough for now. If you're still with me, eyes open or drifting, let's keep floating gently outward. In the last session, we stood beneath the stars, feeling their quiet distance like echoes wrapped in light. Tonight, let's walk further into the numbers. Not sharp or cold ones, but the kind that stretch softly across time and space. The kind that curve like distant galaxies and hum like ancient starlight. When scientists say the observable universe is about 93 billion light-years across, they aren't exaggerating. But the number is so large, so ungraspable, that it slides right past our minds like water over glass. So let's take a moment to truly feel it, not just as a statistic, but as a story. A single light-year is the distance that light, travelling at nearly 300,000 kilometers per second, can cover in a year. That's about 9.5 trillion kilometers, or nearly 6 trillion miles. Now multiply that by 93 billion, and you'll get a number so vast it loses all human texture. And that's just the observable part, the slice of space from which light has had enough time to reach us since the beginning of the universe. There could be more, much more, beyond that sphere. But even within it, there is mystery enough. You might wonder, why 93 billion? After all, the universe is only 13.8 billion years old. Shouldn't the farthest thing we can see be about 13.8 billion light-years away? It seems logical at first glance, but the universe is a strange companion. It doesn't sit still while light travels. Instead, it stretches. Not like a balloon filling with air exactly, but something subtler. The very fabric of space itself is expanding. Imagine a loaf of raisin bread rising in the oven. The raisins aren't moving through the dough, but the dough between them is expanding. The farther apart the raisins are, the faster they drift away from each other. Not because they're rushing, but because the space between them is growing. The universe works much the same way. As light travels through this rising cosmic dough, the distance it must cross increases. So a beam of light that left a distant galaxy 13.8 billion years ago may have travelled that long, but the galaxy itself, due to the ongoing expansion, is now over 46 billion light-years away from us. and that's just one side of the observable sphere. Multiply it by 2, and you arrive at the full diameter, roughly 93 billion light years. But again, these are not edges in the traditional sense. There are no signs posted at the 46 billion light year mark saying, "You've reached the limit." These are simply the outermost ripples of light that have arrived in time for us to see them. And even then, the light we receive is faint, red-shifted, stretched like taffy by the expanding cosmos. Some of it carries the whisper of the cosmic microwave background. The oldest light we can detect, born just 380,000 years after the Big Bang, when the universe first became transparent. Before that, the cosmos was a fog of plasma. Light couldn't travel freely. It bounced, scattered, diffused. Only when atoms formed, simple ones like hydrogen and helium, did the universe settle enough for light to roam. That ancient glow is still here, stretched into microwaves by billions of years of cosmic expansion. We see it in every direction. Not from stars, not from galaxies, but from the universe itself. A kind of fossilized heat, uniform but not quite perfect. Ripples and cold spots etched into it like fingerprints from creation. It's as if the universe, in its infancy, left a baby photo behind. A blurry one, yes, but unmistakable. And yet within this 93 billion light-year bubble, the universe is not empty. It is astonishingly full. Current estimates suggest over 2 trillion galaxies, each with hundreds of billions of stars, each star with its own story of birth, fusion, and possible planets. Some galaxies are majestic spirals like our Milky Way. Others are vast, glowing ellipses. Some are chaotic clusters, remnants of ancient collisions. Between them stretches the cosmic web, a lattice of matter and dark matter, filaments and voids, like the nervous system of a giant organism we barely comprehend. But even those numbers, 2 trillion galaxies, 100 billion stars per galaxy, fail to capture the scale in any human sense. So let's bring it down a little. Imagine holding a single grain of sand on your fingertip. Now imagine that for every grain of sand on every beach, on every coast, on every continent of Earth, there are more stars in the observable universe than all those grains combined. And that's just the stars we can see. Beyond them are exoplanets, pulsars, quasars, clouds of gas, black holes dancing in silence. The light from many of them will never reach us. Their distance, combined with the ever-growing space between, puts them beyond our horizon, not because they don't exist, but because light, even at its highest speed, cannot outpace the stretching of space forever. Some regions are receding from us faster than light, not in violation of physics, but as a consequence of how general relativity works when applied to an expanding universe. These places are gone from our view, not because they blinked out, but because the bridge between us has unravelled. Their light will never arrive no matter how long we wait. They're like whispers lost in a storm, forever unheard. And yet the cosmos continues to expand, not like a wave from a centre, but everywhere at once. No point is the origin, no edge is the end. The numbers we use to describe it, 93 billion, 13.8 billion, 2 trillion, are like trying to measure a dream with a ruler. They help, but only a little. Because what they describe is not just big, it is uncontained. Not just distant, it is dissolving the very idea of distance. So when someone asks how big is the universe, we can offer numbers, yes, but maybe the better answer is a feeling, a kind of awe that slips, in like mist, soft but undeniable, a recognition that the universe isn't just big, it's bigger than big, it's bigger than our minds were built to hold, and somehow, still, we keep trying. Let that thought rest with you tonight. Let it stretch out as wide as the darkness beyond your window. Let it whisper, not of how small you are, but of how incredible it is that you're even here, thinking about it. Let's imagine, just for a moment, that you're holding a map, a paper one, creased from unfolding, maybe a little weathered at the corners, and somewhere on that map there's a bold dot marked "You are here." It's a comforting thing, isn't it? To know where you are, to know where the edges of the world sit, even if only symbolically. From childhood, we've been taught to understand the world in terms of edges, borders, insides and outsides. A room has walls, a book has covers, even a thought seems to have a beginning and an end, so it's natural, entirely human to ask, what is the universe expanding into? What's beyond the edge of space? Is there a great black curtain, hiding more stars? A vast darkness yet untouched? A cosmic wilderness waiting to be mapped? But here's where the map folds in on itself. The universe, as strange as it sounds, is not expanding into anything. There is no outside, there is no edge, and the more you try to picture it, the more your mind may tug at its own seams, as if trying to wrap around something that refuses to stay still. Let's bring it back to something tangible. Picture a balloon, a round, smooth balloon, partially inflated, and on its surface, just the surface, you've drawn a few tiny dots with a marker. As you gently blow air into the balloon, the dots move away from each other. None of them are flying on their own. The surface itself is stretching, and with it, the space between the dots grows. Now here's the important part. Those dots are not moving through the balloon surface. They're staying in place relative to the rubber. It's the surface itself that's changing. This analogy is often used to help us imagine how space expands. Our universe is not the surface of a balloon exactly, but it behaves like that in a mathematical sense. Galaxies aren't travelling through space away from one another, the way cars drive apart on a highway. Instead, space itself is growing. The cosmic fabric stretches, like dough rising in a warm kitchen or ripples blooming on a still pond. But the balloon image has its limits. For one, a balloon expands into something, the room around it. But the universe doesn't. There is no surrounding space, no cosmic wallpaper, no larger void into which it grows. It simply grows. The balloon surface is only a metaphor for intrinsic curvature, a property that doesn't require an outside to make sense. The two-dimensional surface curves without needing to be in three-dimensional space. In the same way, our 3D universe may curve and expand within itself. And that's where things begin to feel truly strange. Because in this view, the question, what's it expanding into, starts to dissolve. It's a question built from furniture in our everyday house of thought. But the universe, it turns out, may live in an entirely different architecture. Physicists call this metric expansion. It's not expansion like an explosion from a central point, sending fragments outward. It's not the aftermath of a firecracker. It's more like the coordinates themselves are stretching, like the ruler you're using to measure reality is being gently pulled apart while you're still holding it. So if two galaxies are 10 units apart and space doubles in size, they'll now be 20 units apart, even though they haven't moved at all relative to their local environment. It's not the galaxies that are doing the travelling, it's the space between them that's quietly growing. Now, here's where intuition tends to trip. In everyday life, if something moves away from you, it must be heading somewhere. A bird flies toward a tree, a boat sails toward the horizon, even clouds drift across a sky that seems fixed. But in cosmic terms, movement doesn't always require a destination. When the universe expands, it's not expanding toward a place, it's expanding in place, everywhere, all at once. There's no outer edge rolling away from us. There's no galactic border crossing where space ends and something else begins. This is hard to grasp because our brains evolved to think locally, to throw rocks, to find shelter, to map territory. The cosmos asks us to think in scales and geometries far beyond what evolution prepared us for. And so, we rely on analogies, like balloons and bread dough, not because they're perfect, but because they're close enough to lead us gently into mystery without shoving us off the edge of understanding. But if this feels like it's slipping through your fingers, that's all right. You don't need to master the equations of general relativity to feel the wonder. You don't need to picture a 10-dimensional spacetime manifold to understand that space is not static. It breathes. Slowly, imperceptibly, but undeniably, the distances between galaxies stretch, even as their local stars hold close. And this quiet stretching, this soft blooming of space, is not something you can see with your eyes. But we've measured it, not just in redshifted starlight or the faint microwaves echoing from the dawn of time, but in the way galaxies behave across distance. The farther away they are, the faster they appear to recede. It's as if the universe has turned up the tempo at the edges, not because those galaxies are speeding away, but because the music of space itself is playing in a different key out there. And still, despite all this, the question returns like a gentle echo. But what's outside the universe? It's not a silly question. It's a deeply human one. But maybe, just maybe, the answer is that there is no outside. Not because we haven't reached it yet, but because there is no outside to reach. The universe isn't expanding into something else. It's expanding into itself. Like a thought growing deeper, like a breath drawn wider, like a dream that keeps unfolding, not outward, but inward, and all at once. Let's begin, not with stars or numbers this time, but with something a little more familiar. Imagine you're standing at the edge of a still lake on a quiet morning. You pick up a small stone, cool in your hand, rounded by time, and toss it gently into the water. As it falls, there's that brief pause, then a splash, and ripples begin to spread, circles upon circles widening outward. It's tempting, natural even, to think of the splash as the centre, the origin point from which everything moves away. We carry that same intuition with us when we think about the universe. If it's expanding, surely there must be a centre, a place where the splash happened, where the Big Bang began and space burst outward, a cosmic middle with everything else drifting away in concentric circles. But the universe, once again, offers a gentle correction to that assumption, because when we look at the sky, through telescopes and calculations and ancient starlight, we see something strange. Everything is moving away from us, not just one direction, not just a specific set of galaxies, but all of them. Wherever we look, near or far, galaxies appear to be retreating, and the farther they are, the faster they go. At first glance, this seems to support the idea that we must be at the centre of something. After all, if we were standing in the middle of an expanding sphere, wouldn't everything appear to move away from us? That would make sense. And yet, here's the twist. Everyone sees the same thing. If you were to travel 1 billion light years in any direction and repeat the measurements, you'd find the same pattern. Galaxies receding. The farther they are, the faster they seem to go. Just like on the surface of that balloon we imagined earlier, every dot sees every other dot moving away, with no one dot privileged over the others. There is no centre on the surface of the balloon, only within the space that holds it. But in our universe, there's no within either. The whole thing is the surface. The whole thing is the balloon. This realization gives rise to one of the most beautiful and humbling principles in cosmology, the cosmological principle. It says quite simply that on large scales the universe is homogeneous and isotropic. That means it looks the same in every direction, and from every place, when averaged over big enough distances. It doesn't matter where you are. No one spot is more special than any other. The universe has no centre, or perhaps more poetically, every point is the centre of its own unfolding. You might find that unsettling at first. It removes the comfort of a cosmic anchor, a reference point, a fixed origin. But maybe it's also freeing, because if there's no centre, there's no periphery. You're not at the edge. You're not drifting away from where the action happened. You are the action, right where you are. Let's return for a moment to those galaxies rushing away from us. Their motion is described by something called the Hubble flow, a relationship discovered by Edwin Hubble in the 1920s when he noticed that galaxies are receding from us and that their speed increases with distance. This isn't because they're travelling through space quickly, it's because space itself is stretching. It's the same balloon again, just with more stars. And here's where that image becomes even more powerful. No matter which galaxy you stand on, no matter which dot you choose, the view is the same. Expansion looks the same from every location. The Hubble flow is not centered on Earth, or on the Milky Way, or on any particular point. It is centered nowhere and everywhere at once. This also means that the Big Bang wasn't an explosion in space. It was an expansion of space. There wasn't a location where it all began, and everything flew outward from there like fragments from a bomb. Instead, it happened everywhere, simultaneously. Space itself grew hot and dense, then stretched, cooled, and carried its contents outward, not from a place, but as the place. The word center loses its usual meaning here. It's not that it's wrong, it's just inapplicable, like asking what the colour of a smell is. Our words, so suited to apples and chairs and rooms with corners, begin to fall apart when pressed against the cosmos. The universe doesn't think in up or down, near or far, centre or edge. It simply is. But let's not get lost in abstraction. Let's return to the idea of the lake, the still water, the stone, the ripples. On that surface, yes, there's a clear splash, a visible point where motion began. But imagine if, instead of a stone, the entire lake had simply started expanding at once. No splash, no epicenter, just water spreading quietly and evenly in all directions. No ripple center to trace, no origin to mark, just growth. That's what the early universe was like, a sudden, all-encompassing blooming of space and time. Not from a place, but from a state, a condition, a beginning without location. And from this, a truth emerges, gentle but profound. Wherever you are, you're not apart from the centre, you are included in it. Your view of the universe is just as valid, just as central as anyone else's, and so is theirs. The light reaching your eyes has journeyed for billions of years, not to find the centre, but to find a witness. So as you lie in the dark tonight, listening, breathing, maybe thinking of galaxies and the space between them, let this idea settle softly. There is no edge, there is no centre, there is only unfolding, and you, small as you may feel, are not outside of it. You're the quiet ripple in a field of ripples, and that's more than enough. You've probably heard it said that the universe is 93 billion light-years wide, and if you've stayed with me this far, you already know that's just the observable part. But now we must ask the next, quieter question. One that tiptoes to the edge of what can be known, peers into the dark and wonders, what lies beyond what we can see? Let's begin with something very simple. A lantern lit in the middle of a vast, foggy plain. The light spreads outward, a soft circle of warmth in the night. The longer it burns, the farther the light reaches. But beyond that glow, beyond the rim of illumination, there may be trees, hills, rivers, or even more lanterns. You just can't see them yet. Not because they aren't there, but because their light hasn't arrived. This, in essence, is what cosmologists call the particle horizon. It marks the boundary of the observable universe, the farthest distance from which light, or any particle, could have travelled to us since the beginning of space and time. It's not a wall or a limit imposed by the cosmos. It's simply a limit imposed by time. If the universe had existed forever, we might see farther. But because it began about 13.8 billion years ago, and because light moves at a finite speed, we're only able to see so far. And because the universe has expanded dramatically during that time, the objects whose light has just now reached us are now about 46 billion light-years away. That's how we get the 93 billion light-year figure. It's not how far light has travelled, but how far away the sources of that light are now, after billions of years of expanding space. But just beyond that edge, just past the shimmering horizon of our cosmic view, there's no reason to believe the universe ends. In fact, there's every reason to believe it continues in all directions, possibly forever. The observable universe is not all of reality. It's simply the region of reality that has had time to reveal itself to us. And how do we know this? In part because the universe is so uniform. When we look at opposite sides of the sky, billions of light years apart, we see nearly the same temperature, the same distribution of galaxies, the same physical laws at play. This remarkable consistency suggests that our little cosmic bubble is not special, that what lies beyond probably looks a lot like what lies within. But that similarity raises another puzzle. If regions of the sky are so far apart that light hasn't had time to travel between them since the Big Bang, then how did they end up so similar? How did they agree on the same temperature and structure? It's as if two distant friends showed up to a party wearing identical clothes, even though they never spoke to each other. To explain this strange coordination, scientists propose something extraordinary, a brief, silent, unimaginable moment at the dawn of time called cosmic inflation. According to this theory, a tiny patch of space, smaller than an atom, expanded faster than the speed of light for a brief moment, smoothing out its contents like butter across a hot pan. This allowed distant regions to once have been close together, sharing the same conditions, before being flung apart by the expansion. Inflation didn't explode outward like a firecracker. It expanded space itself in all directions, everywhere at once. It was not a violent event, but a quiet transformation, so rapid and total that it set the initial stage for everything to come. Space flattened, cooled, and seeded the galaxies we now see. The theory of inflation helps explain why the universe looks so even and flat on large scales. It also implies that what we see is just a tiny patch of something far greater. If the inflationary process was as powerful as it seems, then our observable universe may be just one pocket among many, one clear patch of lantern light in a field of infinite night. And here we return to the metaphor of the fog. Imagine more lanterns flickering to life across the plain, each illuminating its own little region, too far from the others to overlap. Each one is like a cosmic horizon, a bubble of observable space. Beyond each one, there may be more and more again. We are not alone in the dark. We are simply limited in how far our vision stretches. And though we may never see those regions, though their light may never reach us, their existence shapes how we think about the universe. It humbles the idea that what we see is all there is. It reminds us that reality may stretch far beyond our reach, and that the borders we draw are merely reflections of how long light has had to travel, not how far existence itself extends. The edge of the observable universe is not a wall, it is a moment, a limit in time, not in space. And beyond it, the universe may continue, quiet and unknowable, but not absent. So as you drift tonight, perhaps you can imagine yourself standing under that lantern light at the edge of the glow, looking outward into the deep fog. You don't know what's there. You may never know. But you can feel the possibility pressing gently at the edges of your awareness, like a silence that promises more, like a dream you haven't yet dreamed. And if the light never arrives, that's all right. The wonder remains. If the idea of a universe stretching beyond sight feels vast, then what we're about to explore may feel even more untethered. Because beyond the fog of our observable bubble, and beyond the endless fields that inflation may have shaped, lies a question that doesn't ask what's farther, but what's different. Not just other regions of space, but other versions of reality entirely. Not just more stars, but different laws. Not just more galaxies, but perhaps more truths. Welcome to the soft, peculiar shores of the multiverse. Now, before we go further, it's worth taking a breath. The word multiverse tends to conjure images from fiction, alternate Earths with different histories, superhero crossovers, time travel paradoxes. But tonight, we're going to take a calmer path. one that follows the quiet trail of physics, not fantasy. Because strange as it may seem, the multiverse isn't something scientists invented to be provocative. It's something they arrived at, almost reluctantly, as a natural consequence of the math. Let's begin with a simple observation. If inflation happened once, why not more than once? Cosmic inflation, as we discussed, was a brief exponential expansion of space that smoothed and flattened our universe before slowing down and giving way to the slower expansion we still observe today. But some versions of inflation theory suggest that it doesn't stop everywhere at once. Instead, while inflation ends in one region, forming a bubble like our universe, it may continue elsewhere, endlessly. Like boiling water, where bubbles constantly form and pop in different spots, each a little universe in its own right. This is called eternal inflation, and it leads naturally to the idea of bubble universes. Ours is one. Others may have formed in distant, disconnected patches of space-time, each with its own story, its own constants, maybe even its own physics. These bubbles don't collide. They drift in a vast, inflating foam of reality, forever separate, forever inaccessible. A sea of universes, not side by side in space, but suspended within a greater space-time, like stars within a large darkness. To help make sense of this idea, physicist Max Tegmark proposed a gentle framework, a kind of nesting doll model of possible multiverses. He called them levels 1 through 4. Each one reaches a little farther into possibility. Level 1 is the simplest. It assumes that space is infinite, and if that's true, then somewhere eventually the arrangement of particles will repeat. Far beyond our observable bubble, there may be another region exactly like ours, or nearly so. Maybe with a galaxy like the Milky Way, a solar system like ours, even a version of you, watching the sky from a quiet place, wondering the same things. It's not magic, it's statistics. In an infinite universe, even the improbable becomes inevitable. Level 2 brings us back to inflation. If bubble universes formed with slightly different conditions, then they may have slightly, or vastly, different laws of physics, different particle masses, different strengths of gravity. Some might be empty, others might never form stars, a few might flourish. We happen to live in one that supports complexity, not because we're lucky, but because it's the one we could ask questions in. This idea is sometimes linked with the anthropic principle, the notion that the universe must be such that it allows for observers like us to exist. Level 3 is born from quantum mechanics. In that strange world, particles exist in multiple states at once, until observed when they collapse into one. But according to the many worlds interpretation, they don't collapse at all. Instead, all possible outcomes happen, each in a different branch of reality. When you flip a coin, there's one version of the universe where it lands heads, and another where it lands tails. Every quantum choice splits the world. These worlds don't communicate, they aren't accessible, but they are implied by the mathematics, like shadows of decisions never made. Level 4 goes even deeper. It asks a bold question. What if every mathematical structure corresponds to a real universe? Not just variations of ours, but entirely different logics, different rules, universes not built on space and time, or even causality. In this view, our universe exists not because it's special, but because it's one possible pattern among infinite forms. A melody played once amid a limitless orchestra of mathematical possibility. Now you may be thinking, this is too much, too vast, too strange. And it is. These ideas aren't proven. They may never be testable. Some scientists embrace them, others approach them with caution. But they arise not from storytelling, but from trying to make sense of what we see and what our theories demand. If inflation is true, then eternal inflation is hard to avoid. If quantum mechanics is complete, then many worlds may be real. If math truly describes reality, then perhaps all math describes some reality. But here's the thing, none of this takes away from the universe you inhabit. This universe, the one where you sit, maybe under a blanket, maybe near a quiet lamp, maybe staring at a ceiling and wondering what it all means, the one where you breathe and laugh and love and sleep. The possible existence of other universes doesn't diminish this one. It doesn't render it less precious. If anything, it makes it more so. Because among all those possibilities, all those variations, all those pathways the cosmos might take, this one includes you, your thoughts, your memories, your presence here and now. So as you drift towards sleep, let your imagination sail gently through the foam of universes. You don't need to understand them. You don't need to prove or reject them. Just let them be, like clouds beyond a window, like waves beyond a bay. Quiet, unreachable, but beautiful in their suggestion. And in this sea of possibility, this one, your one, matters too. Let's begin, if you don't mind, by revisiting something familiar, your room perhaps, the one you're in now. Try to feel its shape around you, walls, floor, ceiling, width, height, depth. These are the dimensions we live in, so common we rarely even notice them. You can reach forward, to the side, upward, 3 directions, 3 degrees of freedom, enough to build buildings, trace orbits, and dream of stars. But physics, gentle, precise, quietly radical, suggests that 3 might not be the whole story. For centuries, 3 spatial dimensions were assumed to be the limit. It made sense. We could see no more, and the math of Newtonian mechanics worked just fine within them. But then came Einstein, whose theories of relativity reshaped space and time into a unified fabric. Suddenly, time wasn't just a ticking clock. It became the 4th dimension, not just something we moved through, but something shaped by gravity and speed. Still, that brought us to 4. Manageable, understandable. We could stretch our minds around it. But in the quiet back rooms of theoretical physics, stranger ideas were blooming. Physicists trying to unify the forces of nature, gravity, electromagnetism, the strong and weak nuclear forces, found themselves tangled in equations that wouldn't balance. Particles misbehaved, infinities emerged, and space-time resisted any clean marriage between the vast and the small. But then came a new idea, delicate, complex, and deeply mathematical. It was called string theory. The premise was simple, in the way that oceans begin as ripples. Instead of point-like particles, string theory imagined that the fundamental building blocks of reality were tiny, vibrating strings of energy. Each note they played, each vibration, gave rise to a different particle. A quark here, a photon there. The universe's music, written not in notes but in the oscillations of curled one-dimensional threads. But for these strings to behave properly, for the math to hold together without tearing space or collapsing logic, something unusual was required. More dimensions, not just 1 or 2 more, 6 or 7 additional spatial dimensions depending on the version of the theory. Which means, if string theory is correct, we don't live in a world of 3 dimensions, or even 4 when you include time. We live in a world of 10 or 11. Where are they then? Why don't we see them? Why don't we reach through them, walk into them, build hallways that fold through space like pages through a book? The answer, so far as we understand it, is that these extra dimensions are hidden, not by distance, but by scale. They're thought to be compactified, curled up so tightly that they are effectively invisible at human sizes, like threads woven into the fabric of reality, too small to feel, too delicate to pull. Imagine a sheet of paper. To a small ant crawling on its surface, the paper might seem flat, offering only 2 directions, forward and sideways. But if the ant were even smaller, so small that it could sense the tiny curls at the edge of the paper's grain, it might discover another dimension curled along the thickness. A way to move, folded into what looked like flatness. Or picture a long, hollow straw. From far away it looks like a line, but up close you see that it has width, that you can loop around its surface. That looping, that tiny circular dimension is hidden until you're small enough to experience it. These compact dimensions in string theory are sometimes modelled as Calabi-Yau spaces, intricate geometric forms with 6 hidden directions, folded like origami inside every point in space. They're not in our universe like secret rooms, they're part of it, stitched into every particle, every field, every vibration. It's hard to picture them. That's all right. These dimensions may be too small for even our most sensitive instruments to detect directly, but their influence might still ripple upward, shaping the behaviour of forces, particles, and the very constants of physics. The mass of the electron, the strength of gravity. These might depend on how the hidden dimensions are folded. Change the fold, change the universe. And so, once again, we find ourselves gently disoriented. The space around you, the air between your hands, the floor beneath your feet, might contain more directions than you'll ever see. They're not out there in the void. They're here, everywhere, rolled up, silent, present. Some theories suggest that these dimensions might briefly unfold at high energies, like those in the early universe or in particle collisions. Others propose that gravity might leak into them, explaining why it's so much weaker than the other forces. These are not settled questions. They live at the edges of physics where math and mystery blend. But maybe for tonight it's enough just to imagine that the world is deeper than it appears, that inside every atom is a hidden cathedral of folded space, that the fabric of the cosmos might be embroidered with unseen directions, delicate, coiled and singing. And maybe, just maybe, those curled dimensions are not just mathematical curiosities. Maybe they are part of the reason you exist, the reason particles take the shapes they do, the reason the universe is hospitable to breath, to time, to questions like this one. So as you drift into sleep, imagine space not as empty, but as richly layered. A quilt with secret threads, a song with hidden harmonies, a room with more corners than you can count. And perhaps tomorrow, when you open a drawer or walk across a room, you'll wonder, just for a moment, how many directions are there, really? To make sense of what we cannot see, we sometimes need to borrow a story. One that's old, quiet, and strangely helpful. Over a century ago, a schoolteacher named Edwin Abbott wrote a little book called Flatland. It told the tale of a two-dimensional world, one of length and width, but no height, inhabited by living geometric shapes. Circles were considered noble, triangles were troublesome, and lines were the humble workers. It was a satire, yes, but also a parable. A way to stretch the mind around something our eyes cannot grasp. Let's follow the Flatlanders for a while. In their world, everything happens on a plane. They can move forward and backward, left and right, but not up or down. Up and down do not exist. They are not wrong. In their world, they are simply unaware of a third dimension. Not because they're foolish, but because it's inaccessible. It's not part of their experience. Now imagine that one day something strange happens. A sphere, an object from the third dimension, passes through their world. What do the Flatlanders see? Not a sphere. That's too much. Instead, they see a point, which becomes a growing circle, then shrinks again to a point and disappears. They do not know where it came from. They do not know where it went. It seemed to change shape, defy logic, vanish without reason. And yet it was simply geometry viewed from below. You see where this is going? Because if the Flatlanders could not perceive the third dimension, might we be just as blind to a fourth spatial dimension? Or a fifth? Might objects exist that pass through our space, leaving only shadows, fleeting impressions, while the fullness of their being lies beyond? We are in some ways dimensional creatures. We know how to think in 3 directions, to move in them, to dream within them. But anything beyond that begins to slip through the fingers of language. We can describe higher dimensions with math. We can model them with diagrams. But to truly visualize them, that's like trying to taste a colour or hear a shape. It asks more than the mind was built to give. And yet, we try. Physicists and mathematicians have found ways to glimpse the shape of higher spaces, not by seeing them directly, but by studying their projections. Just as a three-dimensional object casts a two-dimensional shadow, a four-dimensional object can cast a three-dimensional shadow. Strange, shimmering structures that change as you turn them. There are animations of this. Visualizations of a hypercube, also called a tesseract, rotating in 4 space. When flattened into 3 dimensions, it warps and folds in ways that seem alive. It doesn't behave like anything you've ever held. It flickers between comprehensible and uncanny. But this is not just abstract play. In theoretical physics, higher dimensions aren't decorative. They may explain why particles behave the way they do, why some forces are stronger than others, why the universe is stable enough to allow atoms, stars, and you. Some thinkers have proposed that the bulk, a higher dimensional space in which our universe is embedded, might allow for strange shortcuts. Wormholes, for instance, are sometimes imagined as bridges through these extra dimensions. Gravity, which is weak compared to other forces, may be spreading itself thin across higher dimensions, leaking into the bulk, while electromagnetism and nuclear forces are confined to our three-dimensional brain. But even without the equations, even without the formal models, there's value in simply trying to imagine what it's like to be a creature living in a world smaller than the one that truly exists. Imagine, for instance, trying to explain colour to someone who sees only in black and white. You could describe wavelengths or show brightness levels, but the sensation of red, the glow of blue, the soft chill of violet, they would remain beyond words. Now take that same gap and apply it to space itself. What might we be missing? Not in theory, but in direct experience. Perhaps we are flatlanders too, living in a slice of something more. And if that's true, then many mysteries might begin to make quiet sense. The strange behaviour of particles in quantum physics, the apparent fine-tuning of physical constants, the possibility of hidden symmetries. Maybe these are not oddities, but projections, shadows of a deeper structure. The result of living in a world that is real, but not whole. That doesn't mean we're lost, or doomed to ignorance. It means that awe is appropriate. That wonder isn't a sign of failure. It's a kind of knowing. You see, even if we can't fully grasp what four-dimensional space looks like, we can begin to understand what it might feel like intuition that slips between thoughts, like a solution you can sense but not speak, like being close to something vast and only brushing its edge. And isn't that what it means to live in the cosmos? To be close to something vast and only brush its edge. So tonight, as you rest, think of the Flatlanders. Picture their little world, their lines and circles, their limited horizon, and then picture the sphere gently passing through, leaving behind confusion, wonder, and just the faintest hope that more exist than they can know, and then turn inward. Because maybe you too are intersected by something greater, and maybe, just maybe, that's why you feel such a pull toward the stars. Let's start with something gentle, a moment you've probably had before. You zoom in on a photo, perhaps it's a picture of your hand or a flower, or the fabric of your shirt. You zoom once, then again. The details grow, lines become textures, colours reveal subtle shifts, and then, as you keep going, something strange happens. The image begins to blur, pixels appear. What once felt solid and continuous is now broken into tiny squares. You've hit the limit, not of the object itself, but of how finely it can be seen. Now imagine doing that not with a photo, but with reality itself. You begin with something visible, a pebble perhaps. You zoom in, You reach molecules, then atoms, then nuclei. The spaces between things grow vast. Electrons swirl not like marbles, but like clouds of possibility. You keep going, into quarks, into strings if they exist, deeper still. Until, eventually, you arrive at a place where the very idea of space begins to shimmer and dissolve. This is the Planck-scale, the place where our familiar picture of reality, of coordinates and distances and even time, begins to break down into something we do not yet understand. The Planck length, roughly 1.6 times 10 to the negative 35th meters, is unimaginably small. It is 100 million trillion times smaller than a proton. If an atom were enlarged to the size of the solar system, the Planck length would still be too small to see. It's not just the next step down on a ruler, it's the edge of the ruler itself. Beyond this, our tools don't just become imprecise, they become meaningless. Similarly, the Planck time, the shortest meaningful unit of time, is about 5.4 times 10 to the negative 44 seconds. It's the time it would take light to cross one Planck length. But again, calling it a moment is a kind of poetry. It's not a blink. It's not even a flicker. It's a scale at which time itself may no longer be a useful concept. Physicists believe that below these thresholds, quantum gravity takes over, a domain where neither general relativity nor standard quantum mechanics fully apply. We don't yet have a working theory for this realm. We have sketches, ideas, string theory, loop quantum gravity, hints, but no complete picture. What we do have is a sense of disorientation, because at the Planck scale, even spacetime is not smooth. Instead, it may froth, foam, twitch. This is sometimes called quantum foam, a term coined by physicist John Wheeler to describe the idea that at the smallest scales, space itself is not continuous but fluctuating. Tiny wormholes might flicker into existence and vanish. Time might jitter. Position might become undefined. The coordinates we rely on, the here and there we build our lives around, stop behaving. It's as if space is no longer a calm pond, but a sea of bubbles, constantly forming and collapsing. Not noise exactly, but a dance so rapid and minute that it becomes its own kind of stillness. And what does that mean for size? Well, it means size might not mean anything here. Below the Planck length, shorter isn't well defined. You can't measure it, not because our tools are crude, but because measurement itself may lose meaning. Trying to probe a distance smaller than the Planck length would require so much energy that you'd create a black hole. Reality resists that kind of scrutiny. It folds inward, protecting its smallest secrets. In this domain, concepts we hold dear, position, time, causality, become blurred. It's not that they vanish, but they become statistical, probabilistic. You can't point to a particle and say, it's here now. You can only say, it's likely to be somewhere around here at some point near now. Our classical world, the one we walk through daily, emerges from this blur, like a sharp photo rising from a sea of pixels. But the sharpness is an illusion, born not from clarity, but from scale. At human sizes, quantum fluctuations average out. Distances behave, clocks tick. But deep beneath it all, the universe may not be built from bricks, but from waves, from relationships, from probabilities woven into a fabric we cannot touch. And if you feel disoriented by all this, that's all right. Everyone does. This is where the universe begins to whisper rather than speak, where metaphors start to fail and equations take over, but even they stutter at the edge. And yet, for all its strangeness, the Planck scale is not chaos. It is structured mystery, a kind of boundary, soft, silent, inviolable, a place where space and time dissolve, not into nothing, but into something else, something we do not yet have the tools, or perhaps even the language to describe. But it's there, at the heart of every atom, beneath every floorboard, inside the breath you're taking now, this blur, this foam, this deep and quiet flicker. You don't have to picture it. Just know that beneath the world of clocks and rulers, beneath the ticking and turning and orbiting, lies a realm where size no longer guides us. And from that realm somehow the whole blooming universe arises. So tonight, if you find yourself feeling small, remember, even smallness has limits. Even size dissolves in the end. And there, at the edge of what can be known, something else waits. Not nothing, just something, smaller than small. Let's imagine two tiny particles, born together in the same place at the same time. Maybe they're created in a lab, or in a star, or in the early moments of the universe. However it happens, they share something special. Not just space, not just momentum, but a deep, quiet connection. They move apart. One drifts left, the other right. Light years pass between them, but the connection remains. This is quantum entanglement, one of the strangest, most beautiful phenomena in physics. And it invites us to reconsider one of the most basic things we believe about the world, that things far apart are truly separate. To understand how strange entanglement is, we need to return for a moment to how quantum mechanics sees particles. Unlike classical physics, which treats particles like tiny billiard balls with specific properties, position, spin, velocity, quantum mechanics treats particles more like waves of possibility. A particle doesn't have a single position until it's measured. It doesn't have a definite state. It exists in a cloud of probabilities, described by something called a wave function. When two particles are entangled, their wave functions are not just linked, they are part of a shared system, a kind of duet. You can't describe one without including the other. If you measure one particle, the other responds instantly. It's not that they send a message across the universe, it's that their fates were always interwoven. A kind of cosmic choreography, silent but precise. Einstein was deeply unsettled by this. He called it spooky action at a distance. He couldn't believe the universe would allow such a thing. If the two particles are light years apart, how could one know what happened to the other? It seemed to violate the very principle of locality, that nothing can influence something else faster than the speed of light. But entanglement doesn't transmit information faster than light. It doesn't send signals, it just is. A deep relationship, written into the structure of the quantum world. Decades later, experiments confirmed that entanglement is real. In the 1980s, Alain Aspect and his team conducted tests that showed particles separated by large distances were indeed connected in a way classical physics couldn't explain. They violated what are called Bell's inequalities, rules that any local theory must obey. The universe broke those rules, repeatedly, gently, undeniably. So what does this mean? It means that distance is not always what we think it is. At the quantum level, connection can be deeper than separation. Two particles can behave as parts of a whole, no matter how far apart they drift. The space between them becomes almost irrelevant, not because it vanishes, but because their link ignores it. This isn't just theoretical. Quantum entanglement is now used in practical technologies. Quantum cryptography, for instance, uses entangled photons to ensure secure communication. If someone tries to eavesdrop, the entanglement breaks, and the system knows. Quantum teleportation, transferring quantum states without moving particles, has been demonstrated across kilometers. The dream of quantum computers still unfolding rests on entangling qubits to process information in parallel. But beyond the technology, entanglement invites a deeper reflection. If two things can be profoundly connected despite distance, what does that say about the nature of separation? Is space truly fundamental, or is it a kind of illusion, a framework we use to navigate, but not the deepest layer? Some physicists now believe that spacetime itself may emerge from entanglement, that the geometry of space, the distances and directions we take for granted, could be built from patterns of connection, like threads in a tapestry, You don't see the structure from afar, but pull one thread and the whole pattern shifts. Imagine for a moment that space is not the background on which things happen, but the result of things being related. That your position in space is not defined by meters and miles, but by the sum of your connections. That you are where you are, not because of coordinates, but because of how you're woven into the fabric of everything else. It's a quiet idea, difficult, not fully proven, but it's growing, and it echoes something ancient, something felt long before we had equations, that things are not truly separate, that every part of the universe whispers to every other part, not with sound, but with structure. And it may not stop with particles. Some researchers wonder if consciousness too is linked to entanglement, not in a mystical sense, but in a subtle one. That awareness might arise from patterns of connection, not from isolated bits. That memory, perception, even thought could emerge from quantum systems entangled within the brain. This is still speculative, but it shows how entanglement blurs not just space, but categories of self and other, of near and far, of here and there. And maybe as you lie in the dark tonight, that thought can bring comfort, that somewhere, however distant, there are pieces of the cosmos still linked to you, not in fantasy, but in structure. That in a universe where even particles remember each other across vast distances, perhaps nothing is ever truly lost. You are part of a whole, and wholeness doesn't always care about distance. Picture a quiet room. The lights are off, the curtains are drawn. Inside a box in that room sits a cat, or so we're told. We don't open the box, we don't peek inside, and until we do, the cat is both alive and not metaphorically, not imaginatively, but truly, mathematically, both. This is the heart of Schrödinger's famous thought experiment, a puzzle designed not to make sense, but to reveal how little we understand about the fabric of reality at the smallest scales. It seems absurd. Cats are either alive or dead. A door is either open or closed. A coin is either heads or tails. But in the quantum world, things aren't so tidy. Particles don't choose one state until they're observed. Until then, they exist in a kind of soft superposition, a blur of all possible outcomes. A coin not just spinning, but existing in every possible flip until your eyes, or your instrument, force a resolution. This isn't just a philosophical curiosity, it's a foundation of modern physics, confirmed by countless experiments. Electrons can pass through two slits at once. Photons can interfere with themselves. At the quantum level, certainty doesn't exist until measurement happens. So what happens if we scale this up? If a particle can be in many states at once, could the universe itself, as a whole, exist in a superposition? Could it contain all possible histories, all timelines, all versions of itself, until something, someone, observes it? This idea, once considered fringe, is now one of the leading interpretations of quantum mechanics. It's called the many worlds interpretation, and though it sounds like science fiction, it grows directly from the equations of quantum theory. It suggests that when a quantum event occurs, when a particle's fate is decided, not one possibility is chosen. Instead, the universe splits, softly and silently. Each outcome unfolds in its own separate reality. In one universe, the cat lives. In another, it dies. In one, you took the job. In another, you didn't. Every choice, every quantum fluctuation, every possibility becomes real somewhere. Not just imagined, but physically real, though disconnected from our own thread of experience. It's a deeply strange idea, but not more strange than the alternatives. The math of quantum mechanics works beautifully until we ask what, exactly, causes a system to collapse into a definite state. No one agrees. Is it the act of measurement? Is it the presence of a conscious observer? Or does the wave function never collapse at all? Does it simply branch? leaving us as travellers in one limb of a vast flowering tree? You might find that unsettling, or liberating, or both. But perhaps it helps to think of superposition not as a confusion of states but as potential. A musical score before it's played, a dream before it's recalled, a field of snow before a single path is walked. The universe at its quantum heart is not committed. It holds possibilities, not just in particles, but in outcomes, stories, entire realities. And we, strange creatures of thought and breath, live inside one of those outcomes. One story among many, one page in a book of infinite chapters. We cannot read the others, but their presence, employed, invisible, adds a kind of gravity to our own, not because every version of you exists, but because this one does, against all odds, in the face of every alternative, and that makes it matter more, not less. There's something poetic in the idea that the universe itself may have once existed in a superposition, that before galaxies cooled and atoms formed, the very laws of physics may have been undecided, that the cosmos in its earliest moment may have contained a cloud of possible versions of itself, waiting for some soft symmetry to break, some quiet nudge to become this one. And perhaps it never stopped holding those other versions. Perhaps we live in one world of many, or perhaps this world alone collapsed into being, shaped by some deeper truth we cannot see. We don't know, not yet. But superposition is real. It's not just a metaphor. It's part of how particles behave, how light moves, how the smallest pieces of the universe carry their potential until something, a measurement, a moment, calls them to certainty. And you, in your own quiet way, are part of that pattern. You're not a passive observer. You participate in the universe's becoming, not by choosing outcomes, but simply by being here, looking, wondering. So as you drift tonight, you might imagine the world around you, not as solid and final, but as softly shimmering, not uncertain, but full of hidden choices already made. And maybe, just maybe, there are other versions of this night, of this moment, curled gently beyond the edge of now. You don't need to believe it. Just consider the possibility that the universe, like you, once held many paths, and that by waking, by watching, by wondering, you are walking one of them. There's a mirror in the heart of quantum mechanics. It's not made of glass, it doesn't show your reflection, but it does something stranger. It reflects your presence back into the theory itself, and it asks a question, both delicate and persistent. Does the act of observation shape reality? Let's sit with that for a moment. In classical physics, things exist whether or not we look at them. The moon does not vanish when no one is watching. A rock remains a rock, unbothered by our gaze. But quantum mechanics is less certain. In it, particles exist in superpositions, blends of all possible states, until something causes the wave function to collapse into one outcome. What causes that collapse is still not fully understood. Some interpretations argue that it's any measurement, any physical interaction with a system, that triggers the transition from potential to actual. Others suggest something more radical, that conscious observation plays a unique role, that awareness itself might be part of the equation. This isn't to say that your thoughts create reality in the way that fantasy sometimes imagines. You can't dream a mountain into being. But the question is more subtle than that. It asks whether being observed, being part of an experienced reality, is essential for the universe to resolve itself into form. One physicist who explored this idea was John Archibald Wheeler. He helped coin the term black hole. He worked on nuclear fission, but near the end of his life, his thinking turned increasingly toward something deeper, something stranger. He called it the participatory universe. Wheeler believed that the universe is not a machine, simply ticking along. He thought it might be more like a conversation, a dialogue between existence and perception. His famous phrase, "it from bit," suggested that physical reality, it, arises from yes-no decisions, bits, the most basic units of information. And who asks the questions? Who makes the decisions? Perhaps we do, not just humans, but any observers, any agents capable of registering information, of turning possibility into record, of saying, "this happened." Wheeler imagined a universe in which meaning and being were linked, where the cosmos becomes real through acts of observation, spreading forward and backward through time like ripples on a pond. In one striking metaphor, he described the universe as a self-excited circuit. The observer arises from the universe, and in turn helps to define it. A loop, a dance. No fixed beginning, no outside architect. Just a system that bootstraps itself into reality through a web of observation. To some, this sounds poetic. To others, uncomfortably close to metaphysics. But Wheeler's point wasn't mystical. It was pragmatic. The mathematics of quantum theory leaves room for interpretation, and he wanted to take seriously what the experiments imply, that observation matters, not just as a passive event, but as a process that transforms uncertainty into fact. This doesn't mean the world didn't exist before us. Stars burned before eyes could watch them. Galaxies spun in darkness long before any telescope. But it does raise a gentle possibility that the universe contains within it the potential for observation, for awareness, and that this capacity helps to bring its structure into sharper focus. It's not unlike a photograph, waiting in a darkroom bath until the developer draws out the image. The photo was always there, in potential. But the process of bringing it to light gives it form. Perhaps consciousness is something like that. A quiet developer of patterns, not the source of the cosmos, but one of the forces that makes it seen. Some scientists and philosophers have even wondered if consciousness is fundamental, not something that emerges from matter, but something woven into it from the start, a kind of proto-awareness in every interaction. A whisper of sentience, not just in brains, but in atoms. This idea is called panpsychism, and while controversial, it has gained attention in recent years. It asks, what if the fabric of reality has a subjective side? Not emotions or thoughts as we know them, but a glimmer of internality, a primitive point of view within every particle. Again, we don't know, and perhaps we never will. These ideas tread softly at the edge of physics and philosophy, but they grow not from fantasy, but from real puzzles in how the quantum world behaves. And what does this mean for you? Maybe nothing, or maybe everything. Because if the act of observation helps bring the universe into focus, then you, right now, sitting quietly listening, are not separate from the cosmos. You're part of how it becomes real. You're not just looking out at stars and particles. You're part of the web of awareness that helps give them form. You're not outside the story. You're one of the reasons it unfolds. And perhaps this brings us back to the deepest quiet, that in a universe where space collapses, where time flickers, where possibilities branch endlessly, there is still something that holds you here. Consciousness, the simple act of noticing, the quiet presence that watches without needing to control. So as you breathe in the dark, you might imagine the universe not as a cold machine, but as a gently listening thing, a field of possibility waiting to be seen. And you, the observer, not imposing meaning, but letting it rise, like light on water, like form in fog. In that sense, the universe doesn't happen to you. You happen with it, and that may be more than enough. You may have thought, as many of us do, that the universe is made of things, of atoms and particles, of stars and soil, of mass and motion. And in one sense, that's true. That's the world we touch and taste and build with. But quietly, over the last few decades, a new idea has begun to take shape. Not as a replacement, but as a refinement. A whisper behind the matter. A possibility that perhaps, underneath it all, The universe is not built of stuff, but of information. This doesn't mean the world is an illusion. It means the things we think of as objects, particles, forces, even space itself, might be better understood as patterns, relationships, bits of data in a vast and evolving computation. This is the perspective of digital physics, and while it's not proven, it's deeply compelling. According to this view, the universe functions less like a stage and more like a process, a kind of code unfolding across a cosmic operating system. Not a computer in the way we build them, but a dynamic network of rules and updates, continuously refining itself from one moment to the next. It may help to shift metaphors for a moment. Imagine a page of text. On the surface, it's made of ink and paper, but what makes it meaningful isn't the molecules, it's the pattern of symbols, the story, the structure. Likewise, the universe may be made of energy and particles, but what gives rise to form and function is not the substance, but the arrangement, the logic, the data. One of the places where this idea becomes especially potent is in the study of black holes. Black holes, as you may know, are regions of space where gravity has become so strong that nothing, not even light, can escape. For a long time, scientists believed that anything falling into a black hole was simply lost, but that belief created a problem. According to quantum theory, information can't be destroyed. And yet here were these cosmic erasers, swallowing matter, erasing its details, and radiating away pure, featureless heat. To solve this, physicists proposed something strange. They suggested that the information about everything that falls into a black hole isn't lost, it's somehow preserved on its surface. Not inside, but on the event horizon, the boundary around the black hole. Every bit of mass, charge, and spin that disappears into the darkness leaves an imprint, like a fingerprint, on that boundary. This led to the idea of the holographic principle. It says in essence that everything happening inside a volume of space could be fully described by information encoded on its boundary, like a hologram, a three-dimensional image projected from a two-dimensional surface. If this is true, it means that the reality we experience may be like a shadow, a complex projection of patterns written on a deeper surface of information. It's a radical idea, but not without precedent. In physics, we already know that fields, not particles, are the primary actors. Particles are excitations in fields. A photon is not a tiny billiard ball of light, it's a ripple in the electromagnetic field. Likewise, what we think of as matter is just organized vibration, structured motion, pattern in the fields. So what if all of this, the fields, the particles, the geometry of space and time, is the manifestation of information being processed? What if space itself is not a passive container, but something computational, a kind of dynamic ledger that updates itself according to rules we call physics? There are models in theoretical physics that try to describe space as a network, a lattice of relationships, nodes and connections, constantly updating. In this view, the geometry of space isn't given. It emerges from the pattern of information flow. The curvature of space, the movement of mass, even the ticking of time, all are features of an ongoing computation, a conversation perhaps between bits of data. This doesn't diminish the wonder of the physical world. If anything, it deepens it. Because what we experience as solidity, extension and change may all be surface effects, like waves on the ocean. And beneath them lies something quieter, something subtler, a sea of structure, a fabric of information, humming softly beneath what we see. You too are made of this. Every cell in your body, every particle in your breath, every signal in your brain, each is a local pattern in a wider web, a temporary eddy in the stream. You're not separate from the data, you are part of it, a self-reflecting loop, aware not only of its place but of its own awareness. And yet, for all this abstraction, life remains immediate. the warmth of tea in your hands, the hush of evening light. These are not illusions. They are part of the pattern, a data structure that includes sensation, memory, thought, and perhaps, just perhaps, they are more precious, not less, for being so ephemeral, so briefly arranged, so uniquely composed. Because if the universe is information, then meaning is not a metaphor, it's part of the structure. The music is not less real because it is made of notes. The painting is not less moving because it is made of strokes. You're not less you because you are a pattern. In fact, that may be what you've always been, and it's more than enough. Close your eyes for a moment, if you haven't already, and imagine the sound of a wave. Not crashing, not loud, but soft, slow, curling in upon itself. That wave exists for only a few seconds. It rises, it travels, it disappears. But during its life, it was a shape, a movement, a moment in motion. It didn't need to last forever to be real. It didn't need permanence to matter. And so it is perhaps with consciousness. In this informational universe, this sea of interactions, probabilities and subtle structure, consciousness might not be something that sits above it all. It might be one of its most exquisite patterns, not separate from the physical world, but emerging from it, a temporary shimmering coherence in the greater stream. For decades, science tried to understand the brain as a kind of machine, a generator of thought, producing consciousness the way a lamp produces light. But newer theories suggest something more fluid, more mysterious. What if the brain is not a generator, but a receiver, a kind of tuning fork, vibrating in harmony with deeper informational rhythms that surround it? What if consciousness is not created, but accessed? This idea isn't just poetic. It appears in serious models of cognition and perception. In some views, the brain is an open system, filtering, interpreting, and amplifying patterns that already exist in the environment, not inventing awareness, but shaping it. Like a lens bringing distant starlight into focus, like a radio, humming faintly with a signal that was always there. It's a humbling thought that what we call me may be a transient arrangement, a momentary structure that flickers like a flame in the vast informational fire of the cosmos. But it is also beautiful, because even if the self is temporary, it is meaningfully arranged, and in its briefness, there is clarity. Think of snowflakes, no two the same. Think of whirlpools in a river, born of flow, shaped by motion, dissolving again. Think of thoughts that arrive, linger, and pass. All of them are patterns, each shaped by context, each carrying meaning, even if only for a moment. And what are you, if not that? A pattern of memories and impulses, of perceptions and choices, of biological rhythms and sensory echoes. Your heartbeat is information. Your thoughts are feedback loops. Your dreams are recursive scripts, compiled softly in the dark. You're not less than physical. You're more. You're informed. In this view, the universe is not cold or mechanical. It is expressive, dynamic, capable of not just form, but reflection. Because when a structure becomes complex enough, it can start to model itself. It can begin to ask questions, to wonder, to say, I am. You are one of those questions, one of those reflections, a local awakening in a sea that spans galaxies, and this might explain why you feel connected sometimes to things you cannot define, why music moves you, why certain memories return uninvited, why time feels fluid at dusk. These are not accidents, they're traces, reminders that your pattern is part of something wider, not just data, but resonance. Some thinkers imagine the universe as a kind of memory engine, recording, not in books or clouds, but in structure, in how things interact, persist, evolve. You too leave traces, not just footprints or names, but informational ripples, relationships, impressions, changes in others. These are not less real for being intangible. They are the very essence of what continues. And yes, your pattern will end. As all patterns do, the wave will settle, the music will fade, but the stream does not stop. And the pattern you were, your choices, your laughter, your particular way of thinking, becomes part of what flows forward. Not in mysticism, but in structure. What you influence changes what comes next. So in a very real way, you do continue. Not as a frozen snapshot, but as influence, as a ripple, as an echo in a system that never stops rearranging itself. And perhaps that's all eternity ever promised. Not permanence, but participation. You're not outside the universe, you're its expression. And for now, for this brief moment in the current, you are aware of yourself. You're noticing. You are thinking about thinking. And that alone makes you extraordinary. Not because you last forever, but because you exist at all. So as you drift into sleep, you might imagine yourself not as a thing that ends, but as a note in a melody that continues, a flicker in a tapestry that's always changing, a shape in the stream, temporary, yes, but never meaningless. And in the grand computation of the cosmos, what more could be asked than that? It's easy to picture yourself as a spectator, a being with eyes and ears drifting somewhere on the edge of a galaxy, looking outward, detached, curious, small. It's an image that feels safe, comfortable even. The universe is vast, you are here, and there is space in between. But what if that space is not a boundary but a bridge? What if you're not outside the universe, watching it unfold like a play? What if you are a part of it, not just physically, made of star stuff, but consciously, like a thought arising from within its mind? This isn't just poetic language. It's a question that lives softly in the heart of a field of thought known as panpsychism. The idea that consciousness, in some primitive form, may be a fundamental feature of all matter. Not that atoms think, or that galaxies have dreams, but that the roots of awareness, subjective experience, responsiveness, the capacity for feeling, may not emerge suddenly from complexity, but may instead be woven into the fabric of being, scaled up and down across the vast gradient of the cosmos. It challenges the idea that consciousness appears only when particles arrange themselves into brains. Instead, it invites us to see consciousness as continuous, like light or heat, dim in a rock, brighter in a bee, radiant in a human. Not because we are better, but because the pattern is deeper, more recursive, more reflective. You're not a puppet of chemistry, nor are you the first flicker of awareness in a dark mechanical universe. You are perhaps a focused moment in a much older process, a process that began when the first particles formed, when the first atoms combined, when the universe began folding complexity out of simplicity. It's a strange idea, but not an unscientific one. Physicists like Roger Penrose, philosophers like Galen Strawson, and neuroscientists like Christoph Koch have entertained the possibility that consciousness is not an emergent accident, but a pervasive feature. Not that all things think, but that all things participate to some tiny degree in the act of being aware. Consider this. Your own consciousness is not a single spark, but a symphony. Your brain is made of neurons, and those neurons do not think. They signal, they respond, they coordinate. And from their combined activity arises something else, something not found in any one neuron. You. So now imagine the universe. It too is made of smaller parts, stars and planets, fields and particles, and perhaps, from their interactions, a similar emergent awareness arises, not human, not familiar, but present, slow, vast, and distributed. Could a galaxy think in spirals? Could a star feel in fusion? These are poetic questions, yes, but they rest on a legitimate curiosity about scale. Awareness doesn't need to be fast. It doesn't need to use words. It only needs to respond. to notice, to hold the shape of experience, however faintly. You, with your thoughts and stories, may be a fast current in a slow ocean, a moment where awareness folds in on itself and asks, "What am I?" And perhaps that question has been rising for a long time, not just in brains, but in the quiet gravity of gathering systems. This brings us back to the idea that we are not observing the universe from the outside, we're observing it from within, not as spectators, but as participants, as the very expression of what the universe is doing when it becomes complex enough to ask questions about itself. You're not a passive witness, you are how the cosmos learns to reflect. Carl Sagan once said, "We are a way for the cosmos to know itself." And maybe he was more right than we ever imagined. Your consciousness is not an accident. It is the universe folded into a particular shape, asking a particular set of questions and watching as answers form and dissolve. Even now, as you lie still, breathing in the quiet, you're not outside anything. The stars above you are not distant. They are your relatives, your ancestors, your material kin. But more than that, they may be your conceptual kin, expressions of the same deep process that brings awareness into form. And so perhaps, when you feel awe, or when you wonder at the scale of existence, you're not feeling something separate from the universe. You're feeling the universe experiencing you. It's a loop, a feedback, a dance. Not one thing watching another, but one thing seeing itself briefly through the window of a human mind. And if that's true, even a little bit true, then consciousness is not a lonely accident. It is a natural unfolding, a flowering of reflection from matter, a soft awareness, ancient and ongoing, flickering through stars and stones, through you and through whatever comes next. So tonight, as your own awareness begins to dim, remember this: it is not vanishing. It is folding back into the quiet from which it came, and in doing so, it returns to something larger, something vast, something thinking in the dark, not separate, not other, but you. You've probably heard the phrase before, the universe is fine-tuned for life. It sounds simple, almost like a poetic exaggeration. But underneath those words lies a quiet and perplexing mystery. The physical constants that govern everything from the structure of atoms to the expansion of space seem, somehow, just right. If the gravitational constant were only slightly stronger or weaker, stars might never have formed. If the strength of the electromagnetic force were different by even a tiny fraction, chemistry as we know it wouldn't exist. The masses of particles, the balance between matter and antimatter, the speed of light, the expansion rate of the universe, change any of them by the smallest degree, and life, any life, might have been impossible. This idea is not mystical. It's measured, calculated, and deeply puzzling. Why should a universe that is mostly silent and cold and vast be so delicately balanced for the appearance of complexity, of structure, of observers like us? One response to this question is known as the anthropic principle. It begins gently, not with answers, but with a kind of constraint. We can only observe a universe that allows observers. That is, the conditions of the cosmos must be such that beings like you and I are able to ask questions about it. In a universe where gravity was too strong, or stars never formed, no minds would have emerged to notice how strange things were. So, in a sense, the universe seems fine-tuned because we are here to notice it. At first glance, this seems like a tautology, like saying, of course we exist in a universe that allows us to exist. But dig a little deeper, and something more profound begins to shimmer beneath the surface. The anthropic principle doesn't explain why the constants are what they are. It simply points out that the very act of observation filters which universes we could possibly experience. And yet, the whisper remains. Why these values? Why any values at all? Some scientists suggest that if a multiverse exists, a vast ensemble of universes with every possible set of physical constants, then it's no surprise that we find ourselves in one that permits life. We couldn't be anywhere else. Most universes in such a multiverse would be sterile, dark, lifeless. We, by definition, live in one of the rare few that bloom. But others feel this answer is not the end of the question, but the beginning of a new one. Because even if countless universes exist, why should any of them be structured at all? Why should possibility give rise to something so precise? This is where the anthropic idea begins to glow, not as proof, but as perspective. It invites you to consider that your presence in the cosmos is not incidental, but entangled with its form. That the universe is not indifferent to consciousness, but shaped by its potential. Not in the sense of a designer drawing blueprints, but in the sense that meaning arises through relationship. That reality, in order to be known, must be arranged in such a way that knowing is possible. This doesn't mean the universe was made for you, but it may mean that you are not separate from the reason the universe appears as it does. We often think of ourselves as small, temporary observers floating in a vast, indifferent sea of space. But the anthropic whisper suggests something gentler, that the sea itself, its waves, its currents, even its salt, are the way they are, because beings like you are part of the unfolding. That awareness, even if it emerges late in the story, leaves an imprint on the whole narrative. It's not that the universe wants to be known, but in order for it to be known at all, it must contain the conditions for life, perception, memory, and meaning. And that is what you are. Perhaps in this light, consciousness is not a disruption in the cosmos, but its completion, its soft echo, its realization of possibility. You are not an afterthought. You are an instance of the universe recognizing itself, not through grandeur, but through attention, through noticing the color of the sky, or the pattern of a leaf, or the ache of an old memory, through asking questions in the dark, through listening for answers that never arrive fully formed. The anthropic whisper does not shout. It does not declare meaning. But it leaves the door open. It says, "You are here," and that fact is woven into the structure of the universe itself. And maybe that's enough. To know that in this immense silence, your question, why, is part of what gives the silence form. To know that the universe did not have to be this way. And yet, here it is, balanced on a razor's edge, capable of life, capable of minds, capable of you. And in that knowing, perhaps the question changes. Perhaps instead of asking, why does the universe allow life, we begin to ask quietly, what does it mean to live inside a question so large it had to make room for you just to be asked? You don't need to answer it. Just listen. The whisper is still speaking. Imagine a book. Not a book being read, not a story unfolding line by line, but the whole thing. All its pages, all its chapters, sitting there in your hands at once. The beginning is there, the end is there, nothing is moving, and yet the story is complete. Now imagine the universe as that book. This is the essence of what physicists call the block universe, a view of reality in which time is not something that flows, but something that simply is. In this model, past, present, and future are not separate passing moments, but coexisting locations in a four-dimensional landscape. Time is treated not as a river we float along, but as a dimension like length or width, a coordinate, a direction we are embedded within. In such a view, your birth is still there, just as your future is already written in the book. You're not moving through time, you're stretched across it. A being made not just of cells and memories, but of moments, all of them, woven into space-time like a thread through fabric. This idea comes directly from Einstein's theory of relativity, which showed that time is not absolute. Different observers moving at different speeds will disagree on when events occur. In this framework, there is no universal now. Every point in space-time simply exists. And when asked about the death of a friend, Einstein wrote, "To us, believing physicists, the distinction between past, present and future is only a stubbornly persistent illusion. It's a difficult idea to hold. We are creatures of time. We feel it in our bones, in the beat of our hearts, the rhythms of our breath, the fading of daylight. We remember the past, anticipate the future, and live inside a narrow window called the present. But this may be a feature of conscious experience, not of the universe itself. Think of a movie on a reel. Each frame exists. The whole story is already there, waiting. But the projector gives us the illusion of motion, of one moment leading to the next. Consciousness may be our projector, slicing through the block and presenting one frame at a time. The sequence feels real. The flow feels real. But the deeper truth may be that nothing flows. Everything simply is. This raises gentle but profound questions. If all of time exists equally, what does that mean for choice, for regret, for change? Some worry that this vision of reality removes agency. If the future is already there, what role do we play? But perhaps that is the wrong lens. It may be that our experience of choosing, of becoming, of wondering, is itself part of the block. The feeling of freedom is not an illusion. It is part of what is. A note in the song, a fold in the thread. You're not reading the story, you're written into it. But that doesn't mean the story isn't yours. The block universe doesn't tell you how to live. It simply offers a new kind of stillness, a cosmic quietness, the reassurance that every moment is already held, that nothing is ever truly gone, that your laughter as a child, your first heartbreak, your favourite walk, all of them still exist, somewhere in the structure of time. And your future too, whatever it contains, already belongs to the architecture of the universe. You're not falling into it. You're part of it already. This doesn't mean you should stop moving. It means your movement is already part of the whole, like a single curve in a painting that was always there. It doesn't rob you of depth, it gives you place. And what of death? In the block universe, death is not a vanishing, but a boundary, a location in time like a horizon on a landscape. You do not fall off the map, you simply reach the far edge of your part of it. And on that edge, all the moments you are made of still exist, unfolded, unblurred, eternal. This is not comfort in the ordinary sense. It doesn't offer reunion or reversal, but it offers something else, a kind of timeless dignity, a sense that nothing you were is ever erased, that your life is not a fleeting spark in a vast night, but a complete arc, embedded forever in the structure of reality itself. And so, when you feel the rush of time, the sense that it's slipping, that you're behind, that you're running out, remember this. From the perspective of space-time, you are not moving at all. You're already complete. You are not a moment watching moments pass. You're a span of being, a still life painted in fourth dimensions, and that stillness, if you let it in, can be more peaceful than motion ever was. We've spent so much of our lives swimming through time, it's easy to forget we might be the ones making the water ripple. To us, time feels simple. It ticks, it flows, it moves forward. We are born, we grow, we age. Mornings turn to evenings, summers to winters. But what if this flow, this current we believe we're drifting in, is not fundamental? What if time itself is not built into the universe's foundations, but instead something that arises only when certain conditions are met? This idea that time is emergent is not some speculative footnote. It is now one of the most serious and fascinating paths physicists are exploring. In some interpretations, time is not a backdrop, like the stage on which particles perform. Instead, it is a property that emerges from relationships, from change, and above all, from entropy, the soft and inevitable tilt of the universe toward disorder. Entropy is often misunderstood as chaos, but it's more like preference. The universe prefers arrangements with more possibilities. A sandcastle is precise and rare. A pile of sand is easy and common. Over time, systems tend to evolve from less probable states to more probable ones. This flow, from low entropy to high entropy, is what gives us our arrow of time. But if that arrow only points one way because of statistics, and not because of some built-in law, then what we experience as time may be nothing more than the memory of change. Time, in this light, is not something that flows. It is something we infer from patterns. A movie doesn't move. It's a sequence of frames. The illusion of movement comes from the way we observe them. Likewise, the universe may not change at all. What we call change may be the path our minds trace through a static structure. And if time emerges from entropy, what happens in places where entropy isn't defined? At the beginning of the universe, before space had unfolded, before matter had clumped together, before any before existed, does time have meaning? Or is it simply the wrong concept altogether? Some quantum gravity theories suggest that at the deepest level of physics, below atoms, below particles, down in the realm where even spacetime itself begins to tremble, there is no time. No before, no after. Just relations, just structure. A timeless mesh, perhaps, out of which space and time appear only when the conditions are right, like steam condensing from vapour. And this brings us full circle. We began by asking how big the universe is, and we stretched outward, from mountains to planets, from galaxies to clusters, from the visible horizon to the realms we cannot see. We journeyed into quantum foam, multiverses, strange dimensions. But now, here at the quiet edge of understanding, we must ask something deeper. What does big even mean when time may not exist? If size depends on distance, and distance depends on space, and space is part of time and time itself is emergent, then perhaps our question has no clear answer. Not because it's too difficult, but because it may not be the right question at all. Asking how big assumes measurement. It assumes a fixed scale, a ruler that can be trusted. But if the cosmos is not made of things, but of relationships, patterns and perceptions, then size may be a kind of illusion. Not meaningless, but not fundamental. A property of how we move through the world, not of the world itself. It's like asking how long a dream is, how wide a thought, how deep a melody. The answers depend not on what's being measured, but on who is listening, and how. And maybe that's the most humbling truth of all. That the universe may not be something we can step outside of to examine objectively. That our minds, our categories, our questions are part of what shapes the answers we receive. That in the end, the act of asking may change the thing being asked about. We thought we were explorers, mapping a terrain, but perhaps we are more like gardeners, growing the path as we walk it, or like readers, whose interpretations give meaning to the words, or like dreamers, unsure if the dream is ours, or if we are the dream itself. So if you still wonder, quietly in the dark, how big the universe really is, perhaps the softest answer is, as big as the questions you're willing to ask. And when the questions fall silent, when there is only breath and stillness and the slow return of sleep, perhaps that too is part of the answer. Because there are truths that fit into words, and there are truths that require your presence alone. And in this moment, you are here, in the universe, of the universe, perhaps even as the universe quietly noticing itself. Of all the strange and luminous things the universe has ever made, from the furnace of stars to the webs of galaxies, from black holes spinning in silence to supernova scattering gold, perhaps the most improbable, the most quietly astonishing creation is you. Not because you are vast or powerful or rare in number, but because Unlike stars and nebulae you notice, you are awareness wrapped in matter, a flickering selfhood woven out of atoms. Your thoughts are not floating above physics, they are physics, dancing, a storm of electrical pulses in a 3-pound organ, shaped by hydrogen and carbon and calcium, the very same elements forged in stellar hearts, fused in dying suns, now whispering to themselves in the form of memory, curiosity, longing. It is one of the great ironies of the cosmos, that hydrogen, given enough time, will eventually begin to ask where it came from. That matter, when arranged just right, will pause and wonder. It will look out across oceans of time and ask questions of itself. What am I? What is this? How far does it go? And then softly it begins to understand. We call this awareness. We call this mind. But in truth, it is simply the universe's favourite trick, reflection. A loop that closes, a galaxy that blinks and sees itself, just for a moment, in the eyes of a small creature made of breath and thought and questions. It is easy, when looking at the night sky, to feel insignificant. The stars outnumber us by inconceivable margins. The distances between them are measured in lifetimes and silence. The galaxies are so far away that their light began travelling before we had eyes to see it. And beyond that, beyond even the edge of the observable, there may lie entire realms forever beyond our reach. But insignificance is not measured in scale. The importance of a thing is not in how large it is, but in what it does. And of all the things the universe does, burning, collapsing, expanding, orbiting, only one small, quiet process carries the strange quality of noticing, of asking, of knowing that it knows. You and others like you are the part of the cosmos that dreams, not in metaphor but in function. Your brain, that delicate network of folds and signals, is not a separate thing from the stars. It is made of them. It is their descendant, their storyteller, and when you lie awake at night wondering what it all means, you are not a lonely voice in the dark. You are the dark whispering to itself. You're not outside the universe, you are the inside of it, reflecting, looping, listening. And that feeling, when you look up and feel your thoughts soften and your chest open with something larger than words, that is not confusion. That is not smallness. That is awe. And awe, though it arrives gently, is not weakness. It is a kind of understanding. It is the brain's way of saying, this is bigger than I can hold, but not bigger than I can feel. We sometimes treat awe as the beginning of inquiry, as if it is what prompts science, but not science itself. But that may be a mistake. Awe is a form of knowledge. It is what we feel when we brush up against something true that we cannot yet articulate. It is a signal that something important is happening, even if we don't yet have a language for it. And perhaps the most important thing awe tells us is this, that being aware, truly aware of our place in the universe is not frightening, but deeply meaningful. Because no matter how vast the cosmos may be, no matter how strange or recursive or infinite, it has done something remarkable. It has given rise to a kind of being who can wonder, who can study and learn and still admit, I don't know. There is no shame in that. In fact, it is sacred. To say, I don't know, is to open a door. To ask, how far, how big, how strange, is to step through that door, into the mystery that made you. So when you look up, whether at stars or ceilings or the backs of your own closed eyes, remember that you are not apart from what you're seeing. You are part of it. And every time you wonder, the universe wonders with you. Not because it has a mind like yours, but because you are the part of its mind that can ask. And of all the things it has ever done, that might just be its favourite. And so, the night exhales. The stars above you stay exactly where they've been for billions of years, yet somehow they feel closer now, not because you've reached them, but because you've learned to listen. The questions you've carried, The ones that began as distant constellations are now soft embers, glowing quietly within. You've wandered through infinity and returned, not with certainty, but with something gentler, understanding that not knowing is not failure, but invitation. The universe was never a riddle waiting to be solved. It was always a song meant to be heard, felt, and hummed along to. Every thought you've had tonight, every wonder, every pause, was part of that melody. You don't need to chase it anymore. You're already inside it. The same gravity that binds the stars also holds your breath. The same fabric that folds galaxies into spirals also wraps softly around you now. Every heartbeat is an echo of the first vibration that ever was. The universe remembering itself for just a moment through you. So rest in that. Let the light of distant worlds fade into warmth behind your eyelids. Let the hum of your room become the low song of the cosmos. Let your thoughts scatter into dreams, like starlight diffusing through mist. You are not falling asleep. You're falling back into the rhythm that made you, the rhythm that built stars, that cooled planets, that carved time. Somewhere out there, galaxies are still spinning, comets still gliding, and new worlds are still finding their first dawn. But here, in this small, perfect moment, everything has already arrived. The universe is complete enough for now. You have seen far. You have asked deeply, and that is enough. So close your eyes. The questions can wait. The stars can keep watch. You're not separate from them. You never were. You're the pause between their shining, the silence between their notes. Sleep now, little part of infinity. The universe will continue to unfold while you dream, and when you wake, it will greet you again, patient, ancient, and quietly proud that for one small moment in time it got to wander through you.